And I've been talking about Azure machine learning since a while now. And today will be a continuity of our previous discussions. So what we talked previously was about the data science process, about what are the steps involved for data science, for like business understanding, data understanding, data preparation, everything that is involved in modeling, evaluation, and deployment. So what's very important about this process is that it is an iterative approach. So at each step of the modeling of the design, we need to go back to the previous step to change something and start over again till we are able to finalize and get a proper model. So in Azure Machine Learning, if you recall, like the workflow is as follows: to import the data, make the pre-processing, split the data between the test and train data sets, bring in the algorithms that we have, and train the model, score, and deploy it. The next thing that we talk about was about data cleansing. So that was in the last webinar where we discussed about how to summarize the data, the steps involved to explore duplicates, to explore null values, exploring the data types, and see how to deal with unbalanced data sets. So just for a quick summary, if you want to read about this again, in case if you missed the webinars or you want to read the articles again, I have two articles talking about this on C# Corner. The first one is about data science process with Azure Machine Learning, where I discuss about all the steps involved. I also have the link to the webinar we did last time here on YouTube video. And in this articles, it goes about everything you need to understand the data set, and we discuss deeply about each step in the data science process. And if you want to read about the second step, which we discussed about the data cleansing tools in Azure Machine Learning, this one was published this morning only. And these articles talk about takes from the first article and continues and continue from there. It shows about data exploration, how to summarize the data, explore duplicates, null values, data types, outliers, balanced data set, and start to understand the tools available inside Machine Learning Studio to clean the data set and prepare the data set. So I also have screenshots about like before and after. So what's very important here is to understand that data cleansing is very, very important part of the data science process, because it is here that when developing the model, you will spend most of your time, and while doing it correctly, it is only here that you will be able to get a huge increase in accuracy just by doing data cleansing and data preparations. For example, in this example that you will read in this article, you will see that just by cleaning the data, the accuracy changed from 74% to 84%. So it's like 10% increase in accuracy. That's a big, big leap in machine learning. So as for today, we start from where we were last time, like what happens when you already perform data cleansing. So today we'll discuss about what are the techniques involved in data science to improve its performance. And we'll look at some of the theory about model improvement. And after that, we'll move into the more practical aspects inside of Machine Learning Studio in Azure. What are the toolings available to help us improve our model accuracy? So for now, if we look at where we were last time, we were inside this data cleansing experiment where we already did everything that we discussed last time. So just for a summary, we have we are using this German credit scoring dataset, which is a dataset of loan data, like past loans data from customers, and we have information such as their yearly salary, duration, credit history, purpose, and so on. And this is like a binary, like a two-class classification a problem that we approached. And the idea is like for each line, we have the customer profile, and then we have this status column here, which is telling us whether Hello? Hello? Did someone say anything? Okay. So Santa was asking if I can increase the text size. Yet let's try like this. Okay, so in this data set, we have the customer profile, the loan details, and at each line we have the information like whether the customer has been able to pay his loan or not. And the idea here is to build a machine learning model like to be able to predict when we have a new customer, to predict whether this new customer will be able to pay his loan or not based on this data set that we have. So if we look at it here, we had all these details and steps that we already talked about, and we were at a point that when we evaluate the model here, we were at about 84% accuracy. So from now here, we'll look at what we can do to improve this again. So the first tools that we have in terms of data science process is called like feature selection. So what it means that maybe we have in our data set, maybe we have some columns that are not relevant to the algorithms, or that's causing the algorithm to behave badly, either because it may be an outlier or because of some reasons it's having a negative impact on the data set. So the first technique is called like a greedy backward selection. That is like you start with all the features in the dataset and you remove them one by one. And at each iteration, you evaluate the model to check about the accuracy. So if you're removing one column and you see that the accuracy went down, this means that like this column was an important column and you probably want to make it back and something like that. So that's like the step, and you would go at each level to remove the columns to try to identify the performance of the features on the data set. Same thing, using the same idea, there's also the greedy forward selection, where this time you start with a new feature and then you add the features one by one, and at each step you evaluate the behavior of adding this feature in the dataset on the machine learning model. So that's like what are the tools of the concepts in data science. And if we try to apply this in Azure machine learning, so we have two tools available. One is the permutation feature importance, which computes the set of columns, the permutation of columns on the dataset. The second one measures the performance of each column that we have on the dataset. So that's the two tools that we have. And if we look at it in practice, how this looks like, so that's our past experiment here. And what we added here is this module called the permutation feature importance. So if once we add it and we run our experiment again, what this shows us, like it shows us based on this permutation of columns, like the combination of all these columns we have here, what are the impact of each of these columns in the dataset based on the combination? So based on the combination of columns we had here, you will see that learn ID and learn installment placement are kind of having a bad effect on this experiment. Like learn ID is not doing anything, and the column other installment plans is having like a negative score here. This means it's having a negative impact on the data set. Let's get to the next experiment where what we do here, we will remove this column from the data set and run the experiment again. So in this experiment here, at the point where we were selecting the columns here, so what I did, I just like excluded these two columns that we took, like loan ID and other installment plans, and run the experiment again. And what happened here, if I look at the performance this had on the model, I see that the accuracy remains the same. That's fine. This happens. But what happens if I look now, if I look at the permutation feature importance again? Now, if I look at the permutation of columns here, I will see that now, based on this set of columns that's in the experiment here, now the column status sex is having a negative impact on this data science experiment. So from here, what I did is I just I copied this part of the experiment here, and I've added it, I've pasted it just here and just here. And now what I did in the select columns, I also now removed the two columns that we just talked, that like the column status sex was having a negative impact. Now at this point in time, I removed this column from the experiment. When I remove this column from the experiment and I evaluate the model again, the outcome again, now I see that the accuracy changed from 0.84 to 0.85. That's a small increase in the accuracy of the data set. Just by removing one column, I'm gaining in accuracy. And that's possible with this permutation feature important task. Now, what I can do next is I can now view what's happening in my new set of data with these columns and see whether I need to remove other columns. But based on the outcome here, it does not look like any column is having a negative impact on the data set. So at this point in time, I may decide to move on. Do you have any questions so far? So from here, we can move to the second tool that we have. So if you recall that we just saw the permutation feature importance column, which talks about evaluating the performance based on the set of columns. The second tool we have is the filter-based selection. This identifies the features in a dataset with the greatest predictive power. That is, this tool here, it will look at all the columns in the dataset and tell us the importance of each feature individually, right? So what happens here, if I look at the outcome of this column, you would see that it looks more or less okay. If one of the columns was giving me like a negative result, I would then remove this feature and run the experiment again to look at the result. So that was just a simple example of how we can increase the performance of our machine learning models just by selecting our features correctly. That is, just by selecting which columns we want to feed inside of the model. Now we can move to the next part, which is about scaling the features. So the idea behind is like when we feed data to a model, a data set, the algorithm only understands like something like this, the columns that we are feeding, right? Like it will not understand what is age, what is credit amount, what is credit score, nothing on that. It will just get the numbers. It's just numbers for the algorithms. But the issue is like, if you just look at this data here, you would see like you have 5, 3000, 0.7, 1, 0. But does it mean like 3000 is the most important feature in this data set, and like 0.7 is the least feature of the data set? That's the idea that we get, right? And that's the idea that the algorithms will also feel like. But let's see what happens if we remove 0.7 in this data set, because supposedly it was the least important feature, and we keep only 3000. So what happens here, it might be that you see like the accuracy falls from 70% to 40%. But why is that possible? Because supposedly we removed the feature which has the least importance. And now what happens if we remove the feature that has the supposedly most important, that is credit amount? You will see that the accuracy falls, but only by 2%. But what happened? What happened is that in reality, credit amount ranges from 1,000 to 10 million. So 3,000 is not a really important feature based on this range. But what about credit score? Credit score ranges from 0 and 1, and 0.7 is actually a very important figure and a very important number in this scenario. So that's why you don't really know what is the weight of each item in the dataset. So to fix that, we need to scale all the features. That is, put all the numeric features on a same scale. So you put everything between a scale of 0 and 1. This means that when the algorithms would look at the data set, it would feel everything would be neutral, like on the same line, because we have scaled all the data set, all the features with the same scale, that is between 0 and 1. So how this applies to Azure Machine Learning? In Azure Machine Learning, we have this tool called the Normalized Data Module. And in the Normalized Data Module, it runs mathematical functions that would convert the numeric data to a common scale. For example, all these three, everything would come on a single scale between 0 and 1. Let's see how this looks like in practice. So we come back to our experiment, coming back to our experiment. So what we did here is we added this normalized data module, and there are several algorithms that we can use to transform this data. So let's see how the data was previously. So before that, everything was 4, 2, 2, and each column has its own scale. And after going through the normalized data module, you will see that everything goes in a scale of between 0 to 1. So it kind of normalize all this data and put it in a similar scale, so that the algorithms do not misinterpret these features. But in this scenario, this did not help our algorithms really, because our accuracy still remains 0.844. That's not bad, because remember that it is an iterative process. We need to understand all the tools, all the techniques that we can do to be able to to improve our data science model. In this scenario, it did not help, but maybe in other cases, it would have helped. The next step is called parameter tuning. To understand parameter tuning, let's first understand what are the parameters that would affect us in this example. So in this example, we are using a two-class classification algorithm, which is in this scenario. Let's look at the experiment. So in this experiment, we are using a two-class boosted decision tree. This is a decision tree algorithm. So a decision tree algorithm works as follows. Let's say we had to take a decision of whether we are going to stay on a new planet, and we need to decide whether this new planet is habitable or not. So what we should do is, we need to see, is the temperature, what about the temperature? Will we be able to live in this temperature or not? Maybe yes or maybe no. If this is a yes, we'll then decide, is there water over there on this planet? Yes or no? If there's water, what we do? If we do not have water, what we do? Now, if we do have water, do we have like food? Do we have flora and fauna on this planet? Yes or no? So we go like this, like that's going down a decision tree. And in this decision tree, we have like these parameters that are used in data science to configure a decision tree algorithms. For example, the maximum number of leaves per tree, the minimum number of sample leaves per node, the learning rate, and the number of trees constructed. And if we try to map these parameters to what we just discussed, it would be as follows. Like this would be like the number of leaves, maximum number of leaves, each level that you go down. At each level, you have these answers like yes or no. This would be like the number of samples at each leaf. And then based on this, you can build several combinations of this tree. And this is the maximum number of trees. So this is how like this simple explanation of decision tree maps to this decision tree parameters. And now these parameters, there are several ways we can configure them in Azure Machine Learning. First, you can use the default one. You can tweak the default one. You can use a parameter range, or you can use the tune hyperparameter module. So if we come back to our experiment here, where let's open the parameter tuning experiment. So that's the algorithms that we'd be using, we are using, and here are the parameters that we are talking about. Number of leaves, minimum number of samples, learning rate, number of trees. That's the parameters. And here, let's make, and here we are comparing these two. We have the same data, but the algorithms configured differently here. Here we are configuring, here we have changed the values a bit. Here we are using like 50 number of leaves per tree, 50. Number of samples per leaf, 40. Here it was 2010. If we just change these two parameters and we compare these two algorithms here, you would see that in this scenario, originally the accuracy was 84%. After changing it, the accuracy is 83%. So it was not beneficial. Let's see what we can do next. What we can do next is we can use what is called a parameter range. That is, each of these parameters, we give a range of values. Instead of giving only one value here, we provide the algorithm with a range of values. And then what happens when you run it, the algorithm will parse each of these values to the parameter and use the one with the highest score. And same thing here, we can use a new module which is called the tune hyperparameter. So what is this? This makes your life easier. With this one, Azure Machine Learning will by itself decide which parameter to parse by randomly selecting numbers and parse it to the parameter. But what's important here is like the maximum number of random sweep. That is, if you put it 10, it will parse 10 random parameters 10 random values to each of the parameters, evaluate the score against the status column, and use the parameters that is most appropriate in this scenario. So it makes your life easier a bit. You don't need to manually insert these values. So what happens here if you evaluate this score? The first algorithms give us a performance of 0.69, which is lower. But if we use the tune-in hyperparameter here, we have an increase in accuracy, which is 0.86. That is 86%. So if you recall, our initial experiment was 84%. Just by doing these tweaks, now our experiment is at 86%. So it is these small steps that you need to take in your algorithms to understand each step and to be able to make the tweaks and make the algorithm better, make the model better to get a better outcome out of the algorithms. The last step of this process would be to evaluate the model. What we have a tool here is cross-validation. This does not have anything to do directly with the model improvement, but it helps us to understand and to make sure that we keep our model as generalized as possible. Let me explain. So inside a normal data science process, what we do, if you recall from our past webinars, we split the data set between the test data set and the trained data set. And we tend to do a lot of computation, a lot of data cleansing, and so on. And we were using this evaluate tool here to view the performance. But what we need to avoid, that all these changes, all this code that we add, to make sure that it is not specific to this set of data that we are training and the set of data that we are testing. Because remember that when our model will be live in production, we are going to get new data. And if we overfit our model, we customize this model to this data set, even though it is we get a high accuracy, it might not work well when we get new data. So in like data science term, we say that our model should be as generalized as possible, and we should avoid overfitting our model. So one of the tools that we have to monitor overfitting is called cross-validation. So right now, normally what we do, we have a set of data which we use to train the model, and we have a small set of data that we are using to test the model. But with cross-validation, it makes like a loop, and at each step, it changes the data. Like it would say, okay, we test with this data, train with this one, and at the next iteration, we'll train with this data and test with this one. At the next iteration, it will test with this data and train with this one. It continues like this. And this will give you an outcome about the behavior of the model at each step of the iteration. So this would ensure that you are not overfitting your model based on a specific set of data, because we test the model with all the parts, all the folds of the data available in your data set. Like if you look at this result here, it would give you the number of folds that we had and the accuracy at each fold. For example, at the first run, we got 76. The second run, we got 83, 82, 82. So it's kind of consistent around 80%. It is an indication that our model is not overfitted, and we are not focusing only on one set of data to train this data set. So that was about the tools that we had to train your data set. So for a summary, what we did is we first cleaned the data. After cleaning the data, we started to see about how we can select the features that we have in the experiment properly. And we saw that just by selecting the features, we can get an improvement in performance. We saw about feature scaling, how we need to align the features, all the features on a single scale to get a better performance. We talked about parameter tuning, and we saw that by using the tune hyperparameter, we were able to get an increase in the model performance. And lastly, we talk about cross-validation and how it can help us to avoid overfitting the model. So with that said, that's it for me for this small session on Azure Machine Learning model improvement. So if you have any questions, do not hesitate to ask me now, else we talk later.
Shavin, Manoj here.
Yes. Hi,
Can
Manoj.
you hear me? Yeah, hi.
Yes.
Thanks for session 7. So I just need to describe what I understood from this sessions. Just clear, clear me if I understood something wrong. So here, what we understood, like from this machine learning activity, we are mostly activity just for the data cleaning point of view. As you use the German credit card data, and you created your own data set, so that is most important. Before reaching to the data sets, you are selecting the what are the required columns and removing where the data is not present in the particular columns. And once we create the data set, then after that you are running the multiple experiment to get like experiment also like out of box applied, and which experiment give the more efficient result. Is my understanding correct here?
Yes.
Okay, and the cross validations, as you told here, the cross validations is nothing but running the multiple experiment on the same data set to analyze the how the accuracy is coming.
Exactly. Because at some point in time in the data set, let me show you, you are splitting the data into two sets. If you keep on training the data on the same set and testing on the same set, you would not know what happens when new data comes in, like here. Okay? When you use cross-validation, you test it on several portions of the data several times so that you can understand the behavior when you get new data.
Okay, okay. Makes sense here. Okay. Thanks, Shavin. That's all from my side. Thanks.
Yes, thank you. Any other questions? So I think all good, Santa?
Yes. I have one other questions right related to machine learning. So
Yes.
if I am using Genesis environment, I can push data to Azure Machine Learning Studio through dataset. I can analyze data, call center data for how many agents are for improving the customer experience for the based on the statistical data. Is it possible?
Can you repeat the
Yeah,
last
yeah.
sentence, please?
Yeah, yes. Actually, for call center data, I can improve for customer experience through machine learning.
Yes, but it depends like from which perspective. What do you have in mind exactly?
Yeah, for improving customer experience. Example, many customers they are providing feedback after call center agent talk to the customer directly. So the customer like feel like the giving the feedback. We are just giving the positive aspect of answers. Example, good, average, and excellent. But customer they saying good, but not really they seeing the good or something else they are feeling it's not option other option to say that feedback. For that kind of things, how we can gather the data to analyze the customer exact feedback?
Okay, I get your questions, but I need to think about it. I can't figure it out right now.
Okay.
But what I've been doing, not for this kind of scenarios, it is not in Azure machine learning,
Okay.
but it is mostly like when we get written feedback from customers,
Okay.
or in scenarios where the agent is chatting with the customers, then we can build some kind of text analytics to get the sentiment of the user throughout this the customer service experience. For example, to identify like based on the chats and so on, like was the customer angry, or based on the voice tone, things like that.
Yeah. Yes.
Yes, things like that you can do. You can even use like speech detection to get the tone of the customer when the customer is speaking over the phone. Like when someone is angry, it is like a specific tone. Things like that you can do, and maybe you can investigate the use of like cognitive services and such tools
Okay.
for these specific scenarios.
Okay. So actually, I thought if I have data for the database, gym database or something else in Genesis side, for that data alone, we can able to analytic the data and get it this feedbacks like the customer positive or negative feedback.
Yes.
Okay. Okay. Thanks, Evin.
Thank you.
Okay. Thank you.
All right. Thank you then. Bye bye.
Thanks, everyone, for your wonderful session. Thanks for your
Yes, you're welcome.